All right, we have our solutions here for our last page of our little booklet, at least the first part of our little booklet. This is the cube root of 27, all to the exponent of 2. Cube root of 27 is a 3, and then 3 squared is 9. All right, 1 to any exponent, doesn't matter, is always just going to equal 1. Part C, we have the fifth root of 1 over 32. Now, there is a rule, that should have been a root sign there, sorry, there is a rule that says that is equivalent to the fifth root of the numerator divided by the fifth root of the denominator. So that 1/5 applies to both of them, and the fifth root of 1 is just a 1, and the fifth root of 32 is a 2. Okay, you could also think of it this way. This is the same as 1 to the 1/5 all over 32 to the 1/5, which then implies that we have that happening. Okay, so that's a 1 over 2 as a final answer. The next one is a negative exponent. I'm going to change that to 1 over. My base stays the same, negative 27, but now that's a positive 2/3. So I'm going to take the cube root of negative 27. That's a 1 on the top. The cube root of negative 27, and then that's all to the exponent of 2. The cube root of negative 27 is a negative 3, and then 3 squared would be a 9. So that's going to equal 1 over 9. Now, 2.5, I'm going to change that into a fraction. 2.5 is the same as 5 over 2. Okay, so 2.5 is the same as 5 over 2. How do we, so that's like 2 and 1/2. Okay, so 2.5 is 2 and 1/2. 2 wholes would have, each one of those wholes have 2 halves in it. So 2 times 2 halves would be 4 halves, plus 1 more is the 5 halves. That's how I came up with that. So that's the square root of 4, all to the exponent of 5. That's going to be a 2 to the exponent of 5, which is 32. And now we have a 1 to the 3/4, which is just going to be 1, because 1 to any exponent is just 1. And then 16 to the 3/4. So on the top, 1 to the 3/4 is 1. And then we want the fourth root of 16, all to the exponent of 3, which is equal to 1 over. The fourth root of 16 is a 2, and then 2 cubed will be 8. So that's 1 over 8. Okay, so hopefully those make sense. Let's keep going here. We want the cube root of 216. Ooh, cube root of 216. I have a feeling that might be 6, but I'll double check that. Yep, it's 6. Okay, and then we have the fourth root of 16. The more you practice these, the more automatic your number facts become. That'll be your 2 there. 2 times 2 is 4 times 2 is 8 times 2 is 16. This is saying the square root of 25. So the square root of 25, all to the exponent of 3. That's going to be a 5 to the exponent of 3, which is 125. All right, next paper. All right, I'm into a variable. Now I'm going to apply my power of a power rule to simplify this. That will be x, and then 6 times 1/2 would be a 3. So that simplifies to x cubed. No roots needed for that. Similarly here, I'm going to apply my power of a power rule, but this 9 also needs to get that 0.5. So we get 9 to the 0.5, and then 2 times 0.5 is just a 1, so that'll be x to the 1. So that's really the same thing as 9 to the 1/2, or the square root of 9, which is a 3. So that'll equal 3x. Next one. Ooh, all right, so I'm going to get a 4, so this is 4 to the 1. Everything in the bracket gets this exponent of 0.5 or 1/2. So this 0.5 is the same thing as 1/2. So that'll be a 4 to the 1/2, or the square root of 4, which will be a 2. And then we have a 0.5 times a 0.5, or a 1/2 times a 1/2, which is a 1/4. Okay, or you could put 0.25 there. We get the square root of 4 is 2, and then we get the fourth root of x. So you can either leave that as an x to the 1/4, or an acceptable answer would also be x, the fourth root of x. All right, let's see what we've got here for part M. Okay, I see power of a power and another exponent in there here. So this is a power of a power, 2 times 1/3. So 2 times 1/3 would be 2/3. So I get an 8x cubed, and that's going to be to the exponent of 2/3. So that 8 gets the exponent of 2/3, and the x also, the x cubed gets to multiply the 2/3, so 3 times 2/3. That gives you 6/3, or you could reduce it here. 3 divided by 3 is just 1. 6/3 is just a 2. That also will equal 2. So you can either reduce. That's helpful if you go to college and they have a math entrance test. Sometimes they don't allow you to use calculators and they want you to know some of these facts. Okay, so now we've got the cube root of 8 all to the exponent of 2, and then we have x squared. Cube root of 8 is 2. 2x, 2 to the 2 is a 4, and then we have our x squared here. Almost done. Last part here. Okay, so everything is going to get that exponent of -1/2. Everything in the bracket. -5 times -1/2 would be a positive 5/2. And then we've got a y, and then 2 times -1/2 would be -1. All right, negative exponent rule is going to apply next. The x to the 5/2 stays on the top. It has a positive exponent. The 9 is going to slide to the bottom, and its exponent is now +1/2. The y slides to the bottom. Its exponent is now +1. And then 9 to the 1/2 is the same thing as the square root of 9, which will be a 3. And I just wrote a 3 because I was thinking of 3. There we go. Back to the drawing board here. So that's going to be a 3, and then y on the bottom of that. All right. Part O, our last question here. So this -0.5 is the same thing as -1/2. So I'm going to think of that when I'm working with that. So I'm going to do my 3 times the -1/2, which gives me -3/2. So I have -4 x cubed y to the, oh darn it, y to the -2. Having trouble getting my stylus to cooperate with me. And then we've got a -3/2 on the outside of that. All right, from here, that -4 has to get the exponent of -3/2. The x cubed gets to, the 3 gets to multiply the -3/2. So that's going to give us a -9/2. Multiply the numerators together and multiply the denominators, the 1 times 2. And then the last one, y, the -2 multiplies the -3/2. Negative times negative will be positive, and then 2 times 3/2 would just be a 3. Okay, now we can start using the negative exponent rule. The y to the 3 is going to stay on the top because it's already a positive exponent. The base of -4 slides to the bottom. Its exponent is now +3/2. And the x slides to the bottom, and its exponent is now +9/2. All right, so let's look at this evaluating piece with the base of -4. That is saying we have the square root of -4, and then we're going to cube that answer, and then x to the 9/2. Now, if you try to square root a -4, in fact, if you try to square root any negative number, you get an error. This has no solution. Okay, this piece has no solution. You can never take an even root of a negative number. You can take an odd root of a negative number. So earlier we had a -64 to the exponent 1/3. We can do the cube root of a negative base, but you can never do a square root or a 4th root or a 6th root or an 8th root or any even root of a negative base, because no number times itself an even number of times will result in a negative answer. It'll always end up being positive. So this has no solution to it. So just a little extra thing to add in to remind you that that is true. All right, now you can work on your do-attain questions.